Dear students, today onwards we are going to study a new lesson, Chapter 7, Coordinate Geometry. This is very important and very interesting topic. Okay, in the 9th classes we learnt about the coordinate geometry, about the Cartesian coordinate system, the x-axis and y-axis, etc. we learnt already. Now, so we know what is this. This is a graph paper. It is called Cartesian coordinate plane. No, otherwise simply we can call it a graph paper. So what is this? Which axis this one? Which coordinate? Yes, x-axis. Now, so this is origin. Origin we are representing O. This one x. This is x dash. Now, so this coordinate, which one? Yes, it is y coordinate. So here y and this one y dash. Okay, this is a graph paper or Cartesian coordinate plane. Okay, now here one point we are marking. Actually here we have to write it. No, this is x coordinate. So 1, 2, 3, 6, 7. No, and here -1, -2. And here 1, y coordinate 1, 2, 3, 4, 5, 6. And what is here? -1, -2, etc. No. Now we are marking a point on this Cartesian coordinate plane. One point P. This is the, for example, this is the position of the point P. Okay, so the coordinate of P is 1, 3. Okay, now we are representing one more point on this Cartesian coordinate or on this graph paper. Okay, so one point we marked here. Name Q, point Q. The point Q is how many distance away from origin? Yes, this x coordinate value is 6 now. Okay, and from y coordinate it is how many point away from origin? Okay, 6 point. So the y coordinate also 6. So how much it is? 6, 6. Okay. Now here we have to find out the distance between PQ. That is our aim here. To find out the point distance between PQ. If it is in the geometry, we can use a scale and measure. Here also we can use a scale and measure, but that is not the actual way of finding the distance between PQ. Okay, this we have to learn one formula. That formula is called distance formula here. Okay, to get this formula, what we have to do? We have to join this point P and Q with this our x and y coordinates. So we can join here now. So now we got a right angle triangle PQR, the point R here. Now, so here how many degree? Yes, it is 90 degree. Now we have got a one type of triangle here. What type of triangle? Yes, this is a right angle triangle. Definite PR. Sorry, the PQ. What is PQ? PQ is the hypotenuse of this right angle triangle. Now, so we are getting a theorem here. Which theorem? Our favorite theorem. Which is our favorite theorem? Yes. What is that? Pythagoras Theorem. We can apply Pythagoras Theorem to get the length of hypotenuse. Definite. To get the length of hypotenuse, we need PR and QR. What is PR? It is base and QR is the height. How can we find the length of PR? So, see, this is the point of P and this is the point of R. Now, so this R is how many unit away from the origin? 6 unit away from the origin. And P is how many unit away from the origin? P is 1 unit away from the origin. So, this total length is how many unit? 6 unit. And out of that 6 unit, how many unit we have taken here? 1 unit. So what is the rest of the value? PR 6 minus 1. Now, so how much this length is? 6 minus 1 unit. How we are getting 6 minus 1? This total length is here. This total length is 6 unit. Out of that 6 unit, how many unit gone from here? 1 unit. So 6 minus 1, 5 unit. Similarly, we have to get the length of QR. Total how many unit? 6 unit. And here how many unit gone? Yes, 3 unit. So what is remaining? 3 unit. Now, so this is 6 minus 3 unit. So 6 minus 1 means how much? 5. And 6 minus 3, 3. So using the Pythagoras theorem, we can find the length of PQ. Now, here we count the blocks and we did the work. Actually, we have to find a theorem here. No, always we have to get a theorem or we should find a formula. Always we cannot perform this kind of activities. We can find out the distance formula now. So this is P, a point P, and this is Q and this one R. This is the point R. This point P is x1, the coordinate of P. Here x1 and this is y1. Here we are taken x1 and this is x2. And here y1, here y2. For example, we take it. Okay. So the point P, the coordinate of P is x1, y1. Therefore, this is x2, y1. At the previous example, we have to find the length of PR. Okay, PR means the distance between P and R. X2 and here how many unit? X1 unit and here how many unit? X2 unit. Therefore, PR equal to the length of PR is x2 minus x1 unit. Now, x2 minus x1 unit. QR equal to y2 minus y1 unit. Y2 minus y1 unit. Similarly, we have to use which theorem? Pythagoras theorem to get the length of PQ. So, we know PQ square is equal to hypotenuse square is equal to base square plus height square. That is Pythagoras theorem. Now, therefore, PQ square is equal to PR how much? X2 minus x1 whole square because two terms are here. Therefore, whole square. Now, next one QR. What is QR? Y2 minus y1 whole square. Now, so QR is equal to y2 minus y1 whole square. This is PQ square. So, what is the value of PQ? PQ equal to, how to take the root? Now, square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is our distance formula. To find the distance between 2 points, we can use this distance formula. PQ is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, now we can do one question, one example. Find the distance between P of minus 1 comma 7 and Q of minus 1 comma 3. So, with this P minus 5 comma 7 minus 1 comma 3, definitely it comes in second quadrant. So, we plotted the point here. It is rough work, not exact point. More or less, the quadrant should plot correct. Okay, second quadrant. This is the point P minus 5 comma 7. This is the point Q minus 1 comma 3. We have to find out this distance between PQ. Okay. So first point we can name. What is the name of first point? X1, Y1. That is minus 5 comma 7. Second point we can name X2, Y2. That is minus 1 comma 3. Now we have to use the formula. Which formula? Distance formula. PQ using. So what we have to write? Using always which formula we are writing, that we have to write using distance formula. What is the distance formula? We learned now. What is that? PQ. Here the name of the straight line is PQ. It's equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Now, so we can get x2 and x1 from the question. Here this is x2 and this is x1. So what is the value of x2? Minus 1. Okay, therefore PQ is equal to root of here minus 1. Minus of minus how much? Yes, plus. So minus 1 plus 5 whole square plus here it is very simple 3 minus 7. How much? Minus 4 whole square. Okay. Now how to do the simplification first? Then only we have to take the square. Now, so how much? Minus 1 plus 5. Minus 1 plus 5 is 4. Therefore root of 4 square plus here minus 4 square. What is the value of 4 square? That is 16. And this is also 16. 4 square also 16 because the square of negative is positive. Now, so how much 16 plus 16? 16 plus 16 is 32. Root 32. So we are getting PQ equal to root 32. So what we have to do? We have to do the factorization of root 32 and try to find the square root. And we know this is not a perfect square. After finding the factorization, we get PQ equal to, this is 4 root 2. The factorization you have to do, everyone should do the factorization and get the answer. PQ is equal to 4 root 2. Okay, units.